All right, here's 12.6 on scatter plots, correlation, and regression lines. So you're going to learn how to make scatter plots for a table of data items, interpret information given in a scatter plot, compute the correlation coefficient, write the equation of the regression line, use technology to find the correlation coefficient and the equation of the regression line, and use the sample's correlation coefficient to determine whether there's a correlation in the population. All right, with scatter plots and correlation. So, is there a relationship between a person's age and normal systolic blood pressure measured in millimeters of mercury? Well, this table here shows in 12.18 age on the this one for the X, and Y is our blood pressure. So, what we see is the table suggests that the older we get, the higher the blood pressure goes. And so, what we're going to do is we're going to actually plot this data as the x-axis is the age and the y-axis is the blood pressure. So if we actually do that plotting of the data, what we're going to do is we're going to get something like this. So we have our age, we have our blood pressure, and so our first one was 37, 133. So we look about 137 and we go up to about 133 and we plot our first point and we called that one A. And then we keep going, oops, we keep going across and we plot all the rest of them A through J. Okay. So once we get all those 10 pieces done, we do get that piece of a graph that looks like that. Now, does it look like there's a relationship here? Well, it looks like as we get older, the blood pressure does go up. So correlation looks like it does have as the age goes up, the blood pressure does go up. So now the key is correlation can often be seen when data items are displayed in a scatter plot. We saw it a little bit here because they had it nicely labeled as going up from the lowest to the highest, and we could see that both of them went up and down, went up at the same time. And so, although the scatter plot indicates a correlation between age and blood pressure, we can't actually conclude it's increasing age that causes a higher blood pressure. So, what we can say is, well, maybe our vascular system changes, including a reduction in elastic tissue and arteries, and this increasing stiffness of arteries causes a blood pressure increase for people in their late 30s and older, and it's not actually the age itself that's causing this. So we can't really say that one is causing the other. So establishing that one thing causes another is extremely difficult, even if there's a strong correlation between those things. So, for example, as the air temperature increases, there's an increase in the number of people stung by jellyfish at the beach. Now, this doesn't mean that an increase in air temperature causes more people to be stung. It might mean more people are hot, and so they get into the water, which then causes more people to get stung. So, the key thing and takeaway is the correlation is not necessarily causation. So that's kind of a key issue that we have to remember that doesn't one doesn't necessarily cause the other. All right, so let's pause there and we'll come back for some more.